Now I'm going to go through the proof that y bar is the minimizer for this equation here as a function of mu. If these kinds of proofs aren't your thing, then just skip it, and in the subsequent lectures the same thing, though I'll give the same caveat before each time I do something like this. If you do intend to pay attention to the proof, you don't need to know either calculus or linear algebra, but ideally you'll be very comfortable with mathematical notation. So for example, if you've had calculus in your past, you've forgotten the specifics of calculus, but you're pretty familiar with mathematical notation and working with mathematical notation, and that's all you need. Okay, so let's go ahead and do it. This is the quantity I'd like to minimize as a function of mu. My yi's are my observed data points. I'm going to subtract and then add y bar. So I've just added 0, changes nothing. So I can have an equal sign there. I can expand this square out, and I get this term, twice the cross product term, and then this term right here. Let's look at this term right here. Notice this doesn't depend on I, so I can pull it outside of the sum, out here. Then notice this guy right here, I can distribute the sum across it. So I get summation yi, and then if I add up y bar, which doesn't depend on I, if I add it up n times, I get ny bar. But notice, I would define y bar as 1 over n times the summation yi. Add up my observations and divide by n is the average. So in other words, ny bar is equal to the summation of yi. So this is 0. That whole term then is 0. Moving on to the next line, I have summation yi minus y bar squared, adding those up, and summation y bar minus mu squared. This quantity is the sum of a bunch of squared things. Has to be positive. So if I throw it out, my equal sign gets turned into a greater than or equal to sign. I've only gotten smaller by throwing out a bunch of positive things that I'm adding. Let's summarize. This function, for any value of mu, is larger than or equal to the specific case when we plug in y bar. Therefore, y bar has to be the unique minimizer of that equation.